Hello guys, nice to meet up with you again. Today I'm here to discuss the question from SPM 2019 paper 2 question number 8 of probability distribution. For this question, I already cropped the English part. Okay, let's look into the question. Diagram 4 shows a darts target board at a dart game booth in the fun fair. This is the target board. The booth offers 3 darts per game. The customers have to pay Rm5 to play a game. A toy bear will be given to customers who are able to hit the bull's eye for the 3 darts thrown in a game. Bob is a dart player. By average, he hits the bull's eye 7 times out of 10 darts thrown. Okay, question part A. Bob would play the game if he had at least 90% chance to win at least one toy bear by spending Rm30. By mathematical calculation, suggest to Bob whether he should play the game or otherwise. 7 marks. Part B. What is the minimum number of games that Bob needed so that he can get 4 toy bears? 3 marks. From the early part of the question, it was given that Bob is a dart player. By average, he hits the bull's eye 7 times out of 10 darts thrown. What is this that you understand? You should know that this is the probability of Bob hits the bull's eye. So each dart, the probability for Bob to hit the bull's eye is 0.7 because 7 divided by 10 is 0.7. Now each game is given 3 darts. So each game 3 darts. What is the probability for that? It should be 0.7 cubed. So 0.7 times 0.7 times 0.7. This will be the first dart, the second dart, the third dart. So this will be given 1 mark. And the answer is 0.343, 1 mark. Okay, then after that, part A. Bob would play the game if he had at least 90% chance to win at least one toy bear by spending Rm30. By mathematical calculation, suggest to Bob whether he should play the game or otherwise. Where is the keyword that you can identify from this paragraph? Bob would play the game if he had at least 90% chance to win at least one toy bear. So at least one toy bear is one of the key words, right? Then spending Rm30 is also another keyword. What do you understand by to win at least one toy bear? Look into this. This is 90% to chance to win. Therefore, the probability to win at least one toy bear. Okay, the probability to win at least one toy bear. At least one toy bear. Okay, one toy bear. So then spending Rm30, you know that per game is 5 ringgit. So 30. How many games? Yes, it will be 6 games. Then you come back here, you continue. So it will be, this is 1 mark. Okay, it will be probability of 1 toy plus probability of 2 toys plus the probability of getting the third toys and so on until where do you stop? Where do you stop? You stop here until the probability to get the six games that he played. He got all toys for each game, okay, or for all the games. So, or you may use a shortcut, okay, easy way to determine the probability of at least one toy bear was won. Okay, 1 minus probability of no toy bear was won, right? So then we go on to our working. Okay, right. Then in order to continue, please remember to recall the formula correctly. Probability of X equals to R equals to NCR, probability of the success to the power of R, probability of failure, N minus R. So where the probability of P and Q, P plus Q should be equals to 1. So these are very important to you. You should be able to recall the formula. Okay, then we go on by this, the probability to win at least one toy bag. So we are going to use this 1 minus P probability of X equals to 0. So it should be 1 minus 6. My N is 6. My R is 0. Okay, my R is 0, right? Then P is 0.343. I get it from here, the 3 dots. So Q, I got it from here. Okay, where Q equals to 1 minus P, okay, to the power of respectively. Right, then okay, this you will get 1 mark. Okay, this whole thing, you get 1 mark. And when you get the whole part of this to determine the probability to win at least one toy, the whole part of this correctly, either you follow this or this, you will get 1 mark. Then continue pressing your calculator, you'll be able to get this, and then continue with your calculation, you get this. And this you convert into percentage. Okay, this you will get 1 mark. Okay, because this is the probability. You convert into percentage, 91.96%, and this is greater than 90%. Okay, it is greater at least. So this is more. 91.96% is more than 90%. So what do you say? Bob should play or shouldn't play? Yes, Bob should play the game. So that's you get 1 mark for this part, right? Right, for this question, part A, you have answered. So total 7 marks question. So let's check. 1 mark, 2, 3, 4, 5, 6, 7. Yes, you hit all the marks. Congratulations. For part B, what is the minimum number of games that Bob needed so that he can get 4 toy bags? Okay, for this question, we use the formula of mu equals to NP. Okay, M is the number of games and P is the probability that just now for 3 dots, which is 0.343, and mu is the 4 toys. So but now asking for minimum, how are we going to place the inequality here? So it should be mu should be less than NP, right? So then I rearrange the position of NP. Mu is less than NP means that NP is greater than mu. So N is the minimum number that we are looking for, and P is the probability, and mu is the 4 toy bags. Okay, so now this is what we get. Okay, so this is 1 mark for this probability. You use the right probability, right? Then this is, and you sub mu with 4, another 1 mark here. Then by working out, you will get your N greater than 11.66. So the integer that greater than 11.66 should be 12. Therefore, your n is 12. Finally, you get your answer for 3 marks. 1, 2, 3. Congratulations. That's all for today. Thank you.